Ladies and gentlemen, today we are glad to give a brief introduction on the revolutionary technology 5G. We will first give an overview of 5G technology and then the communication protocols in 5G system, especially in physical layer, are introduced. The remaining part of this presentation will cover the deployment use case of 5G and its economic influence on various industries. First, let's have an overview of 5G technology. In this part, we will cover the definition of 5G, the main features and improvements over 4G. Also, the 5G network architecture, the key technologies that enables 5G are also introduced. 5G, or the fifth generation of wireless technology, is a transformative leap forward in cellular communications. It promises faster speeds, lower latency, and more capacity than 4G. Key features and improvements of 5G over 4G include enhanced mobile broadband, ultra-reliable low-delay communications, and large-scale machine-type communications. These features enable 5G to support a wide range of applications such as high-definition video streaming, autonomous vehicles, and smart cities, as well as Industry 4.0. The 5G network architecture consists of radio access network, 5G new radio standard, and the core network. The wireless access network is responsible for managing the radio resources and providing the necessary connectivity between user devices and the core network. In the context of 5G, the RAN is based on the 5G new radio standard, which is an evolution of the existing LTE technology. The 5G core network is the central component responsible for managing various network functions and providing connectivities between the radio access network and external networks. Key technologies enabling 5G include millimeter wave spectrum, massive MIMO, beamforming, network slicing, and edge computing. The use of higher frequencies in millimeter wave technology enables the transmission of a large amount of data at very high speeds, which is a key requirement for the next generation 5G wireless communication system. MIMO stands for multiple input, multiple output, and is a wireless communication technology that uses multiple antennas at the transmitter and receivers to improve the capacity and reliability of the wireless link. Beamforming reduces interference and improves the network performance by focusing the transmitted energy in the desired direction. Network slicing allows operators to allocate private network resources for different services and applications to achieve a customized quality of service. Edge computing enables computing and data processing to be performed closer to the edge of the network. This is where the data is generated. This allows for faster processing and a lower latency. That helps to improve the user experience. In this part, we will cover the communication protocols in 5G system. Let's first have an overview of the communication protocols in 5G system. "5G system utilizes a variety of communication protocols across different layers of the network architecture to ensure efficient, reliable, and secure transmission of data. These protocols can be broadly categorized into three layers: the physical layer, the data link layer, and the network layer. In the following parts, we will mainly introduce protocols in physical layer. Physical layer protocols including waveform design, channel coding, modulation schemes, frame structure and numerology, MIMO and beamforming techniques, synchronization and reference signals, hybrid automatic repeat request, and retransmission schemes. In terms of the waveform design, 5G adopts CP-OFDM and DFTS-OFDM. technologies, which improve signals transmission efficiency and allow for a higher spectrum utilization. CPO-FDM is the primary waveform used for downlink transmission to optimize spectral efficiency, while DFT-SO-FDM is mainly used for uplink transmission, providing higher power efficiency. For channel coding, 5G adopts LDPC and polarization code, two advanced coding technologies that ensure high reliability and lower latency under various transmission conditions. Both LDPC and polar codes provide capacity-achieving performance. LDPC codes can easily be designed for different code rates and block lengths, making them suitable for a wide range of use cases with diverse reliability and latency requirements. Polar codes are used specifically for the control channel in the uplink. Since they demonstrate robust performance across various channel conditions, they are very suitable for the use in control channels where reliable communication is critical. For modulation schemes, 5G systems support a variety of advanced modulation technologies, such as QAM, QPSK, and higher order modulation schemes. These schemes can be dynamically adjusted according to the channel conditions and application requirements to achieve high speed and reliable data transmission. Frame structure and numerology play a critical role in defining the organization of time and frequency resources for data transmission. The length of the frames and subframes in the 5G system can be adjusted according to different use cases, such as real-time video transmission and Internet of Things device communication. This flexibility in resource allocation allows 5G networks to be better adapted to different scenarios and needs. MIMO and beamforming technology play an important role in the 5G system. Some of the physical layer protocols used to support MIMO and beamforming include channel state information, which refers to the knowledge of the wireless channel's properties, such as amplitude, phase, and time delay. Precoding is a technique used in MIMO system and to pre-process the transmitted signal in a way such that the receiver can efficiently decode the multiple spatial streams. Beam management is a set of procedures used in 5G new radio to establish and maintain optimal beamforming configurations between the transmitter and receiver. Synchronization and reference signals play a key role in 5G systems. Synchronization signals are used to enable time and frequency synchronization between the transmitter and receiver. Reference signals are used to support channel estimation, demodulation, and measurements in 5G new radio systems. Synchronization and reference signals play a crucial role in the initial access, channel estimation, and demodulation processes. Hybrid automatic repeat request and retransmission schemes are key technologies to achieve high reliability and low latency communication in 5G systems. HARQ is an efficient error control technology that combines forward error correction and automatic retransmission request capabilities to improve data transmission reliability. When an error occurs in the received packet, HARQ requests retransmission and uses the received error packet to assist in decoding, thus reducing retransmission times and latency. In 5G new radio, two primary retransmission schemes are employed for HARQ. In chase combining, the transmitter sends the same encoding data for each retransmission. When the receiver detects an error in the received data, it stores the corrupted data in the buffer and requests a retransmission. Upon receiving the retransmitted data, The receiver combines it with the stored data from the previous transmissions to improve the overall signal quality. Increment redundancy is a more sophisticated retransmission scheme in which the transmitter sends the additional parity bits rather than retransmitting the same encoded data. When the receiver detects an error, it stores the received data in the buffer and requests a retransmission. The transmitter then sends new parity bits which are combined with the stored data to improve the overall signal quality and potentially correct the errors.
Well, I will talk about the deployment and infrastructure of 5G. We know that with the advancement of global deployment, countries are actively allocating spectrum and conducting auctions to promote the development of 5G infrastructure. Infrastructure requirements include small cells, backhaul and fronthaul, fiber optic networks, data centers, and edge computing. We know, for example, in China, the government is accelerating the construction of 5G networks and invests heavily in fiber optic networks to provide high-speed, high-quality connection for 5G. Meanwhile, the United States, Europe, and other Asian countries are also actively promoting 5G infrastructure construction and invest heavily in R&D and deployment of innovative network technologies. In this process, small cell technology has become the key to solving urban signal coverage issue. For example, wireless carriers can install small cells in buildings, streets, and squares to improve signal quality and coverage. In addition, to meet the low latency, high bandwidth requirements of 5G networks, carriers are actively deploying fiber optic networks. The construction of fiber optic networks in countries like China, the US, and Germany has achieved significant results to provide reliable infrastructure support for 5G networks. Data centers and edge computing are also essential components of 5G infrastructure. To meet the computing capacity requirements of 5G application, enterprises and carriers are investing in building more data centers. For example, internet giants such as Alibaba, Amazon, and so on are accelerating the deployment of data centers worldwide. At the same time, edge computing technology has attracted widespread attention because it can deploy computing capacity at the edge of the network, which can reduce latency and improve user experience. For example, autonomous vehicles, remote healthcare, and smart manufacturing are actively exploring the application of edge computing technology, which can achieve more efficient and secure 5G service. Then we will talking about the use cases and applications of 5G. Well, we are focused on three topics. First one is the customer applications, then it's about industrial applications, and last we will focus on the public safety and emergency response. 5G customer applications are extensive and diverse, including enhanced mobile broadband and multimedia service such as high-definition video streaming and live broadcasting, which provide users with a faster and more stable internet experience. And also, we know AR and VR technologies will be more widely used in 5G area. It can provide immersive experience for users in education, tourism, shopping, and also other fields. And about the gaming industry will also benefit from 5G's high speed and low latency features, which make cloud gaming and multiplayer online games smoother. Well, in the industrial sector, 5G will be combined with Industry 4.0 to promote the deployment of smart manufacturing. For example, 5G can provide real-time data transmission for factories, making automated production lines and robots more efficient. Also, smart cities will use 5G technology to achieve intelligentization of various urban facilities, such as smart lighting and smart parking. In agriculture, 5G can support precision farming by monitoring soil, climate, and other environmental conditions in real time through devices, which can provide data support for agriculture production. And the healthcare industry will also undergo transformation, with 5G providing high speed, low latency data transmission for removed diagnosis and removed surgery, allowing for better utilization of um, medical medical resources. In the energy and uh, ut- utilities section, 5G will help in the deployment of smart grids and remote manipulating application, improving energy using efficiency. Well, public safety and emergency response are other important application areas of 5G technology. 5G can provide real-time, high-definition video transmission and rapid data sharing for public safety, which can allow police, fire, and other departments to respond more quickly. In addition, 5G can support the application of drones, robots, and other devices in emergency rescue and improve emergency response capabilities. Well, the widespread adoption of 5G will have a profound impact in global economy, driving transformation and growth across industries. For example, 5G infrastructure construction will create a large number of investment and employment opportunities, such as base station construction, network maintenance, and technological R&D. Uh, Furthermore, 5G will create new market opportunities such as IoT, intelligent transportation, and remote healthcare. Well, in conclusion, the widespread application of 5G will have a profound impact in both traditional and emergency industries, providing strong momentum for economic growth, employment, and innovation. With the continued development and popularization of 5G technology, uh, we have reason to believe that the further future will usher in the more beautiful and intelligent society. Thank you.